Hello, this is the section 1.3 lesson. In this section we're going to talk about comparing numbers. Now comparing numbers is fairly simple, but in this section we want to talk about why we compare numbers the way we do. And we're going to see how we use big ideas in mathematics to explain the why. So let's start off with a ridiculously simple example. Compare the numbers 2 and 5. So what we mean by that is which number is bigger and which number is smaller. Well, obviously the number 2 is smaller than the number 5, and so we would write an expression like this: 2 is less than 5. Or alternately, we can say that 5 is greater than 2. Both those expressions mean the same thing, they're just written in slightly different ways. Now, one way to remember which direction the inequality goes is you can think of this inequality as like a little alligator, and the alligator wants to eat the bigger number. Or when I was in school, we used, instead of an alligator, it was a Pac-Man, right? Pac-Man wants to eat the bigger number. So whatever way you want to remember that is fine with me. Alright, so that's a ridiculously simple example. Let's move on to something a little more complex. Compare the numbers 28 and 30. Well, we already know how to compare numbers like this. We compare the digits on the left. So what I mean by that is we write the numbers down, 28 and 30, and we line them up so the tens digits are right on top of each other, the ones digits are right on top of each other, and then we start comparing the numbers on the left. And we see that 2 is less than 3, and so that means that the number 28 is less than the number 30. Okay. So that's how we compare the numbers. What we want to talk about next is why that method works. And to explain the why, we're going to use a big idea from mathematics, specifically the idea of the place value system that we've talked about in the past two sections. So to review the idea of the place value system, we start off here on the right with our ones digit. We bundle 10 individual objects together to get our tens digit, bundle 10 of those together to get our hundreds digits, and so on and so forth. So each digit in our number represents a different size bundle. On the right, these represent individual objects. Then we have bundles of 10, bundles of 100, and so on and so forth. So one important thing to remember is that each place value is 10 times the value of its place to the right. And because of that, we call it the base 10 system. So let's use this idea to explain why this method for comparing numbers works. So let's go back to this example of 28 and 30, and let's draw pictures of what these numbers represent, 28 and 30. So 28 means that we have two bundles of 10, so we'll let those little boxes represent 10, and then we have 8 individual objects, 1, 2, 3, 4, 5, 6, 7, 8. The number 30 means that we have 3 bundles of 10 and then no individual objects. And so to compare these numbers, let's start off by comparing the biggest bundles. We see here is that in the 28 we've got just 2 bundles of 10. Here we have 3 bundles of 10. Now over here we don't have any individual objects. We do have 8 individual objects there, but remember that this one additional bundle of 10 is bigger than these 8 individual objects. And so 30 has more bundles of 10, and so for that reason 30 is bigger than 28. So that's why that method works. 30 is bigger than 28 because 30 has more bundles of 10 than does 28. Those 8 individual objects in 28 don't make up for that lost or that missing bundle of 10. So that's how we use the place value system, this big idea in mathematics, to explain why that method for comparing numbers works. So let's use this example to compare some decimals. Let's compare the numbers 0.099 and the number 0.100. So here's an illustration from the book, and here they've drawn a picture of what each one of these numbers means. So here we've written these numbers down so that their decimal points line up, and then they've drawn pictures to illustrate what these numbers mean. So here's their key. 1 dot represents 1 thousandths, And so the 0.099, we have 9 thousandths, so 9 individual dots. And then this 9 here in the hundredths place represents 9 bundles of 10. And then we have 0 here in the tenths place, so we have 0 bundles of 100. Now the number 0.100, we have 0 individual objects, we have 0 bundles of 10, but we have 1 bundle of 100. So we see that we've got 1 bundle of 100, no bundles of 100 here. So because we have more bundles of 100, this number 0.100 is bigger than the other number. So 0.100 is bigger than the number 0.099. So again, we've used the place value system to compare those numbers. So let's kind of summarize our algorithm here for how we compared positive numbers. The first step is to line up the decimal points. Make sure that the decimal points are lined up. And then step 2, we compare the digits on the left. The larger digit is going to correspond to the larger number. If the digits are equal, then keep moving one place to the right. And our place value system justifies why this works. Okay. So again, why does this work? It's because the digits to the left represent larger quantities than the digits to the right. Specifically, those digits on the left represent bigger bundles of objects than those digits on the right. Now, that was a method for comparing positive numbers. Let's talk about another method for comparing numbers using number lines. And so number lines, the method here is fairly simple. You plot your number on the number line. A number that's to the right is going to be bigger than a number that's on the left. So larger numbers are going to be on the right, smaller numbers are going to be on the left. So number lines are fairly simple, and they have the advantage that number lines work for not only positive numbers, work for decimals, they also work for negative numbers. So let's just real quickly illustrate how we can use this to compare the numbers negative 0.27 and negative 1.5. And so we plot these numbers on the number line just like we talked about in last section. We're going to put a 0 here, we're going to define 1 unit, and then we're going to go 1.5 units to the left, plot the number negative 1.5. We're going to go 2.7 units to the left, plot the number negative 0.27, and there's how we plotted our numbers. So now we see that negative 0.27 is to the left of negative 1.5, and so we'd say that a negative 2.7 is less than a negative 1.5. And so there's how we can use a number line to compare negative numbers. Now let's look at another way that we could compare negative numbers. Let's again compare these numbers negative 2.7 and negative 1.5. And let's interpret these numbers in terms of money as we did in our last section. So in terms of money, the number negative 0.27 means that someone, call him Bob, owes $2.70. The number negative 1.5 means that somebody, call him Joe, owes $1.50. So the thing to observe here is that Bob owes more money than does Joe. So that means Bob has less money. So that means that the negative 2.7 is going to be less than a negative 1.5. So there we further justified this conclusion that negative 2.7 is less than a negative 1.5. So that's it for this section. Your assignment before next class period is to read section 1.3 from the textbook, and also in your packet there's a worksheet called Misconceptions in Comparing Decimals. This is going to list some common mistakes that students make in comparing decimals. And so in our activities in class we'll be talking about that worksheet.